Moving heavy weapons, armored vehicles, and strategic systems has always been one of the greatest challenges in military operations. When roads, bridges, and rail networks cannot be trusted or simply do not exist, armies rely on off-road vehicles built at an extreme scale. These machines were engineered to carry enormous loads across mud, sand, snow, ice, and broken ground, often under combat conditions and in remote regions far from support infrastructure. From Cold War missile carriers and super-heavy tank transporters to modern logistics giants, each vehicle in this collection represents a deliberate push beyond conventional limits. Size, weight, and power were not design excesses but necessities driven by strategy, survivability, and mobility. Together, these vehicles define the outer edge of what military engineering has achieved on land when off-road capability and sheer mass became mission-critical. MAZ 7907, the largest wheeled land vehicle ever built for military use. The MAZ 7907 stands as the absolute pinnacle of wheeled military vehicle engineering, representing the most extreme expression of size, mass, and ambition ever applied to an off-road land platform. Conceived during the late Cold War, it was designed to move payloads so heavy that no conventional road vehicle, bridge, or transporter could support them. In terms of sheer scale, no other wheeled military vehicle before or since has surpassed it. Development of the MAZ 7907 took place at the Minsk automobile plant during 1983 to 1985, at a time when Soviet strategic doctrine emphasized mobility and survivability of nuclear forces. The vehicle was intended to transport ultra-heavy strategic systems across undeveloped terrain, allowing them to disperse away from fixed infrastructure and remain hidden from enemy surveillance. This requirement drove engineers to abandon traditional mechanical drivetrains in favor of radical solutions. The MAZ 7907 featured an unprecedented 12-axle configuration with 24 wheels, all powered through an electric transmission system. A gas turbine engine generated electricity, which was distributed to individual wheel-mounted electric motors. This design allowed precise torque control across the vehicle's massive footprint, enabling it to move loads that exceeded 150 to 200 metric tons under controlled conditions. Fully loaded, the total mass of the vehicle placed it among the heaviest land vehicles ever constructed, wheeled or tracked. In terms of dimensions, the MAZ 7907 measured nearly 30 meters in length and more than 4 meters in width. Its enormous size made it unsuitable for public roads, which was precisely the point. The vehicle was intended to operate on unprepared terrain, ice roads, compacted snow, and hardened ground in remote regions, including Arctic and subarctic zones, where frozen surfaces could temporarily support extreme weight. Extensive insulation, heating systems, and cold-resistant components were integrated to allow operation in sub-zero environments. Testing took place during the mid to late 1980s and demonstrated that the vehicle could indeed move its intended loads. However, the trials also revealed severe limitations. Maneuverability was poor, fuel consumption was extreme, and maintenance demands were immense. Operating the MAZ 7907 required specialized crews, support vehicles, and carefully prepared routes, making routine deployment impractical. By the late 1980s to early 1990s, shifting strategic priorities and economic collapse led to the cancellation of the program. The MAZ 7907 never entered full operational service, but its existence marked the absolute upper boundary of wheeled military vehicle design. Historically, the MAZ 7907 remains unmatched. It was not merely large, it was an engineering outlier, built at a moment when limits were intentionally ignored. As the largest wheeled land vehicle ever built for military use, it remains a symbol of Cold War excess and the extraordinary lengths nations were willing to pursue in the pursuit of strategic mobility. MAZ 7310, 8 axles, built to move strategic weapons off-road. The MAZ-7310 was one of the most formidable off-road military vehicles of the Cold War, designed to move strategic weapons and oversized military equipment across terrain where conventional roads did not exist. Built for scale, strength, and reliability, it represented the Soviet Union's belief that mobility itself was a strategic weapon, especially in an era dominated by nuclear deterrence and rapid response doctrine. Development of the MAZ-7310 took place at the Minsk automobile plant during the late 1970s, with the vehicle entering service in the early 1980s. It evolved from earlier MAZ heavy tractor designs, but was significantly enlarged and reinforced to meet the demands of transporting increasingly heavy missile systems, radar units, and support equipment. Unlike civilian heavy trucks, the MAZ-7310 was designed from the outset to operate off-road, including on dirt tracks, frozen ground, compacted snow, and improvised launch sites. The most distinctive feature of the MAZ-7310 was its 8-axle, 16-wheel configuration. Measuring over 22 meters in length and weighing more than 40 metric tons when empty, it ranked among the largest wheeled military vehicles ever placed into operational service. When fully loaded, its total mass increased dramatically, yet the vehicle remained mobile due to careful weight distribution across its many axles. This allowed it to traverse soft ground and ice roads without immediate structural failure, particularly during winter operations. Power came from a high-output diesel engine, coupled to a heavy-duty transmission designed to deliver torque evenly across all driven wheels. Central tire inflation allowed the crew to adjust tire pressure on the move, improving traction on sand, mud, snow, or ice. These features made the MAZ-7310 especially valuable in remote regions of the Soviet Union, including Siberia and Arctic-adjacent zones where infrastructure was minimal and environmental conditions were severe. The MAZ-7310 served in multiple roles, but its most critical function was as a transporter for strategic missile systems and their support equipment. It was also used to carry mobile radar installations, fuel units, and large engineering components. In many cases, it operated as part of dispersed mobile formations, complicating enemy detection and targeting. Despite its capabilities, the MAZ-7310 had clear limitations. Maneuverability was restricted by its length and turning radius, and fuel consumption was extremely high. Maintenance required trained crews and significant logistical support, especially in remote areas. Its effectiveness was also highly seasonal, as thawing ground reduced load-bearing capacity. Historically, the MAZ-7310 occupies a crucial place in military vehicle development. It proved that wheeled platforms, when built at sufficient scale, could perform roles once reserved only for tracked vehicles. As an 8-axle giant built to move strategic weapons off-road, it helped define the upper limits of practical wheeled military transport and set the stage for even larger missile carriers that followed. MAZ-537, the Cold War heavy hauler that redefined military logistics. The MAZ-537 was one of the most influential heavy military vehicles of the Cold War, a machine that fundamentally changed how armies moved their largest and heaviest weapons across off-road terrain. While later vehicles surpassed it in size, the MAZ-537 established the blueprint for modern, heavy military logistics and remains one of the most important off-road haulers ever built. Development of the MAZ-537 began at the Minsk automobile plant in the late 1950s, with the vehicle entering service during 1963 to 1964. It was created to address a growing problem within Soviet military doctrine: the rapid increase in the weight of tanks, missiles, and engineering equipment. Rail transport and fixed roads made such assets predictable and vulnerable, so the solution was a powerful wheeled tractor capable of towing extreme loads across unprepared terrain. The MAZ-537 featured a 4-axle, 8-wheel drive configuration and was powered by a massive V12 diesel engine derived from tank technology. This engine produced extraordinary torque, allowing the vehicle to tow loads exceeding 65 metric tons, including main battle tanks, ballistic missile trailers, and heavy engineering systems. With a length of roughly 9 meters and an empty weight approaching 22 metric tons, the MAZ-537 was enormous for its time, and instantly recognizable by its wide stance and blunt utilitarian design. Off-road capability was central to its role. Large, low-pressure tires, permanent all-wheel drive, and a robust suspension system allowed the MAZ-537 to operate on mud, sand, snow, and frozen ground where conventional transporters failed. Central tire inflation enabled crews to adjust traction on the move, a critical advantage in rapidly changing terrain. These features made the vehicle especially effective in Siberia and other remote regions where roads were unreliable or non-existent. The MAZ-537 served primarily as a prime mover rather than a cargo carrier. It towed tank transporters, missile launch trailers, radar units, and oversized military equipment, often operating far from established bases. Its ability to function independently of roads allowed Soviet forces to disperse heavy assets, reducing vulnerability to surveillance and attack. This mobility was a strategic advantage during a period defined by nuclear deterrence and rapid escalation scenarios. Despite its strengths, the MAZ-537 had limitations. Fuel consumption was extremely high, and long-distance operations required careful logistical planning. Maneuverability was limited by its size, particularly when towing large trailers, and maintenance demands were substantial. However, its mechanical simplicity and durability ensured long service life. The MAZ-537 remained in active use well into the late Cold War and beyond, with many examples later adapted for civilian heavy haulage and industrial roles. Historically, it represents a turning point in military transport design. By proving that wheeled vehicles could reliably move the heaviest military loads off-road, the MAZ-537 redefined military logistics and paved the way for the even larger strategic transporters that followed. MZK, T-7 Devet Dive Mobile Missile Power on Unprepared Terrain. The MZK-T-79221 is one of the most imposing and strategically significant off-road military vehicles ever built, designed to ensure the survivability and mobility of intercontinental ballistic missiles in the harshest environments. As a mobile launcher platform, it represents the culmination of decades of Soviet and later Russian experience in building super-heavy wheeled vehicles capable of operating far from prepared roads. Development of the MZK-T-79221 began in the late 1980s at the Minsk Wheel Tractor Plant, with the vehicle entering service during the late 1990s to early 2000s. It was created specifically to carry and launch the RT-2PM-2 Topol-M and later RS-24 Yars intercontinental ballistic missiles. These systems required a transporter that could handle extreme weight while remaining mobile across forests, dirt tracks, frozen ground, and other unprepared terrain. The vehicle features a massive 8-axle configuration with 16 driven wheels, all powered through a heavy-duty drivetrain designed to distribute torque evenly. Fully loaded, the MZK-T-79221 weighs well over 120 metric tons, placing it among the heaviest wheeled military vehicles ever placed into operational service. Its length exceeds 22 meters, and its width approaches 3.4 meters, giving it a commanding presence unmatched by most military ground vehicles. Off-road capability was a core design requirement. The MZK-T-79221 uses a sophisticated suspension system and central tire inflation, allowing crews to adjust ground pressure in real time to suit mud, sand, snow, or ice. This enables the vehicle to operate in environments where conventional missile transporters would be immobilized. In winter conditions, frozen terrain allows the launcher to disperse across wide areas, complicating detection and targeting by adversaries. The crew compartment is heavily protected and climate-controlled, designed for long-duration missions in extreme temperatures. Advanced navigation, communications, and control systems allow the launcher to operate independently while remaining integrated into strategic command networks. Despite its size, the vehicle is engineered to maneuver through forested areas and along narrow routes, though movement requires careful planning and trained crews. Operational use of the MZKT 79221 focuses on constant mobility. Missile units regularly relocate between concealed positions, temporary launch sites, and support areas, reducing vulnerability to preemptive strikes. This concept of dispersed, road-mobile nuclear forces has been a cornerstone of Russian strategic doctrine since the late Cold War. The MZKT 79221 represents one of the most advanced realizations of mobile missile warfare. It demonstrates how extreme vehicle size can be successfully combined with off-road mobility, reliability, and operational practicality. As a platform built to move and deploy the most powerful weapons ever created on unprepared terrain, it stands as one of the largest and most consequential off-road military vehicles in history. MZKT 79291. Modern strategic mobility at extreme scale. The MZKT 79291 represents the modern evolution of super-heavy off-road military vehicles, embodying decades of experience in strategic mobility while pushing scale, reliability, and adaptability even further. Developed as a next-generation platform, it reflects the continued importance of mobile ground systems in an era where survivability depends on movement, concealment, and operation far from fixed infrastructure. Development of the MZKT 79291 took place during the 2000s at the Minsk Wheel Tractor Plant, building directly on the engineering lineage of earlier missile transporters such as the MAZ 79117 and MZKT 79221. Unlike its predecessors, the 79291 was designed with greater modularity in mind, allowing it to support a wider range of strategic payloads beyond a single missile system. This flexibility made it suitable for emerging military requirements that demanded adaptability alongside sheer size. The vehicle features an 8-axle configuration with 16 driven wheels, all optimized for extreme off-road use. Fully loaded, the MZKT 79291 exceeds 120 metric tons in total mass, placing it firmly among the largest operational wheeled military vehicles in the world. Its length extends beyond 22 meters, with a wide stance that enhances stability when carrying tall or top-heavy loads across uneven terrain. Off-road performance is central to its mission profile. The MZKT 79291 incorporates an advanced independent suspension system combined with central tire inflation, allowing real-time adjustment of ground pressure to suit mud, sand, snow, ice, or frozen soil. This enables the vehicle to move across terrain that would immobilize conventional heavy trucks, including forest tracks, unpaved routes, and winter ice roads. In Arctic and subarctic environments, frozen ground significantly expands its operational reach. Crew survivability and endurance were major design priorities. The cab is heavily reinforced and fully climate-controlled, capable of sustaining operations in extreme heat or temperatures below -40 degrees Celsius. Modern navigation systems, satellite communications, and onboard diagnostics allow the vehicle to operate independently for extended periods while remaining integrated into command and control networks. Operationally, the MZKT 79291 supports the doctrine of dispersed strategic mobility. Rather than relying on fixed bases or predictable routes, units equipped with such vehicles continuously relocate, reducing vulnerability to surveillance and precision strikes. This constant movement transforms size from a liability into an advantage, as the vehicle's ability to traverse unprepared terrain creates an almost limitless set of possible operating locations. In the historical context, the MZKT 79291 stands as a symbol of modern military engineering at an extreme scale. It demonstrates that even in the age of satellites and long-range weapons, ground mobility remains a decisive factor. By combining massive size with refined off-road capability and modern systems integration, the MZKT 79291 secures its place among the largest and most sophisticated off-road military vehicles ever built. ZIL-135, twin-engine brutality for off-road missile transport. The ZIL-135 was one of the most unconventional and aggressive off-road military vehicles of the Cold War, designed with a singular purpose: to move missile systems across terrain where roads were unreliable or non-existent. While not the heaviest vehicle of its era, its radical engineering choices and unmistakable layout earned it a lasting reputation as one of the most distinctive, large off-road military platforms ever built. Development of the ZIL-135 began in the late 1950s at the Likachev automobile plant in Moscow. It entered service during the early 1960s, a period when Soviet military doctrine emphasized mobility, dispersion, and rapid deployment of tactical missile forces. Engineers faced a difficult challenge: how to ensure sufficient power and redundancy for missile transport in environments where mechanical failure could not be tolerated. The solution was extreme. Instead of a single large engine, the ZIL-135 used two separate gasoline engines, each powering one side of the vehicle. This twin-engine layout eliminated the need for a conventional differential and allowed the vehicle to continue moving even if one engine failed. While mechanically complex and fuel-hungry, the system delivered brutal, reliable traction across mud, sand, snow, and frozen ground. The ZIL-135 featured an 8-wheel configuration arranged in 4 axles, with a distinctive gap between the front and rear wheel pairs. This layout improved obstacle clearance and reduced ground resistance on uneven terrain. Measuring roughly 11 meters in length and weighing over 20 metric tons empty, the vehicle was large for its time and capable of carrying or launching heavy missile systems such as the Luna and later tactical rocket platforms. Off-road capability was the defining feature of the ZIL-135. Large, low-pressure tires, independent suspension, and high ground clearance allowed it to traverse terrain that immobilized conventional trucks. Central tire inflation enabled real-time adjustments for changing surface conditions, a critical advantage during rapid deployments. In winter operations, frozen ground allowed the ZIL-135 to operate deep into areas inaccessible to road-bound vehicles. However, these advantages came at a cost. Fuel consumption was exceptionally high, maintenance was demanding, and synchronization of the twin engines required skilled crews. Steering characteristics were also unconventional, relying in part on differential engine speed rather than purely mechanical systems, which made handling challenging at higher speeds. Despite these drawbacks, the ZIL-135 proved effective enough to remain in service for decades, with numerous variants produced for missile transport, command roles, and special military applications. It was exported to several Allied states and became a familiar presence in Warsaw Pact forces. The ZIL-135 stands as a symbol of Cold War pragmatism taken to extremes. It sacrificed efficiency and simplicity in favor of raw off-road survivability and redundancy. As a twin-engine brute built to carry missiles where no roads existed, it secured its place among the most memorable and influential large off-road military vehicles ever built. ZIL-29061. Screw-driven mobility for the worst terrain on Earth. The ZIL-29061 occupies a unique and unconventional place among off-road military vehicles. Unlike massive wheeled missile carriers or heavy-tracked platforms, it was engineered to operate where even those machines completely fail. Its design philosophy abandoned speed, payload, and conventional mechanics in favor of one overriding requirement: the ability to move across terrain that is otherwise impassable. Development of the ZIL-2 9061 began in the late 1970s at the ZIL Special Design Bureau in the Soviet Union. The vehicle was created to support military and space recovery operations, particularly the retrieval of cosmonauts landing in remote areas of Siberia. These landing zones often consisted of deep snow, frozen marshes, peat bogs, broken ice, and shallow water, environments where wheeled and tracked vehicles were useless. The defining feature of the ZIL-2 9061 is its twin Archimedes screw propulsion system. Instead of wheels or tracks, the vehicle uses two large rotating cylindrical screws mounted beneath the hull. As the screws turn, they bite into snow, mud, ice, or waterlogged ground and pull the vehicle forward. This system allows continuous movement across soft or unstable surfaces, including terrain that would instantly immobilize conventional vehicles. In terms of size, the ZIL-2 9061 is smaller than strategic transporters, but its operational role places it among the most extreme off-road military machines ever built. It measures approximately 8.5 meters in length and weighs around 4 to 5 metric tons. While modest in mass, its terrain access capability is unmatched, allowing it to reach locations no other ground vehicle can. Power is provided by dual gasoline engines, each driving one screw independently. This configuration offers redundancy and ensures limited mobility even if one engine fails. The vehicle is fully amphibious and capable of transitioning directly between land, snow, ice, and shallow water without preparation. Its maximum speed is very low, and operation on hard surfaces such as pavement or rock is inefficient and damaging to the screws. The ZIL-2 9061 entered service during the late 1970s to 1980s and became a critical component of Soviet and later Russian search and rescue units. It was commonly transported to recovery zones by larger vehicles or aircraft, then deployed independently into inaccessible terrain to complete final approach and extraction missions. The ZIL-2 9061 demonstrates how extreme environments force radical engineering solutions. By rejecting traditional mobility concepts, it achieved a level of terrain access that no wheeled or tracked vehicle could match. As a screw-driven platform designed for the worst terrain on Earth, it remains one of the most specialized and effective off-road military vehicles ever created. DT Trizdesmit PM Vityaz, articulated mass built for military extremes. The DT-30 PM Vityaz is one of the most formidable off-road military vehicles ever placed into sustained operational service. Designed to function where roads, bridges, and stable ground do not exist, it represents the peak of articulated tracked vehicle design for extreme military environments. Its purpose is simple but demanding: move massive payloads across terrain that would stop almost any other land vehicle. The origins of the Vityaz family trace back to Soviet Arctic mobility research during the late 1960s to 1970s, when military planners recognized the strategic value of regions dominated by snow, ice, swamps, and tundra. The DT-30 PM variant emerged later, during the 1980s to 1990s, as the heaviest and most capable version, developed by the Vityaz Machine Building Company to meet expanding military logistics and weapons transport requirements. The DT-30 PM consists of two large tracked units connected by a reinforced articulated joint that allows movement in both vertical and horizontal planes. This articulation is the key to its mobility. It enables the vehicle to climb steep slopes, cross pressure ridges, negotiate uneven ice, and maintain traction across broken or shifting ground. Fully loaded, the DT-30 PM can exceed 60 metric tons in total mass while carrying payloads of up to 30 metric tons. Measuring roughly 16 meters in total length and more than 3 meters in width, the DT-30 PM spreads its immense weight across wide tracks, producing extremely low ground pressure. This allows it to travel over deep snow, soft tundra, and marshy terrain without sinking. One of its most critical military advantages is its amphibious capability. The vehicle can swim across rivers, flooded ice fields, and coastal waters using track propulsion, allowing uninterrupted movement in environments where water barriers are unavoidable. The DT-30PM entered operational service during the late 1990s to early 2000s and has been widely used by military units operating in northern and remote regions. It has transported missile systems, radar installations, fuel tanks, engineering equipment, and mobile command modules to locations unreachable by wheeled vehicles. Its reliability under temperatures below -50 degrees Celsius makes it especially valuable in Arctic and subarctic deployments. Crew survivability is a central design feature. The forward unit houses the driving cab and crew compartment, fully insulated and equipped with powerful heating, navigation systems, and communications suitable for whiteout conditions. The rear unit is modular and can be configured for cargo, fuel, workshops, medical facilities, or living quarters, allowing rapid adaptation to mission requirements. The DT-30PM demonstrates how articulation, rather than sheer horsepower alone, can define off-road dominance. By combining enormous mass with flexibility, amphibious movement, and proven reliability, it stands as one of the most capable military transport platforms ever built for the most extreme environments on Earth. A TT heavy artillery tractor, the backbone of Soviet off-road power. The ATT heavy artillery tractor was one of the most important off-road military vehicles produced by the Soviet Union, forming the mechanical backbone of heavy logistics, artillery movement, and later polar and strategic transport concepts. While it lacked the sheer spectacle of later missile carriers, its strength, reliability, and adaptability made it a foundational platform upon which many larger and more specialized vehicles were built. Development of the ATT began in the late 1940s, with the vehicle entering service during 1952 to 1953. It was produced at the Kharkov Locomotive Factory and was derived from components used in heavy tanks, particularly the T-34 lineage. This origin gave the ATT exceptional durability and torque, qualities essential for hauling large artillery pieces, engineering equipment, and military trailers across unprepared terrain. The ATT was a fully tracked vehicle, weighing approximately 20 to 23 metric tons, depending on configuration. It measured roughly 7.5 meters in length and was powered by a high-output diesel engine optimized for low-speed pulling power rather than speed. Its wide tracks distributed weight effectively, allowing it to operate on mud, snow, sand, and frozen ground where wheeled vehicles routinely failed. This capability made it indispensable across the Soviet Union's vast and infrastructure-poor regions. In operational use, the ATT served as a prime mover for heavy artillery, radar systems, missile support equipment, and engineering assets. It was capable of towing loads exceeding 25 metric tons, often under extreme conditions. The enclosed cab provided basic protection for the crew and allowed operation in severe weather, including sub-zero temperatures common in northern and eastern theaters. One of the ATT's greatest strengths was its versatility. Beyond its original artillery role, it became the basis for numerous specialized variants, including command vehicles, radar carriers, engineering platforms, and experimental transport systems. Most notably, the ATT chassis formed the foundation for early Soviet polar vehicles, including the original Kharkovchenka Antarctic tractor. In convoy and land train configurations, multiple ATT units were used to move supplies across long distances in Arctic and subarctic environments. The vehicle remained in service throughout the 1950s, 1960s, and well into the 1970s, both in frontline units and support roles. Its mechanical simplicity made it easier to maintain in remote locations, a critical advantage where spare parts and technical support were limited. Even as newer vehicles entered service, the ATT continued to be used because of its proven reliability. The ATT heavy artillery tractor represents the practical core of Soviet off-road power. It was not designed to impress, but to work relentlessly under conditions that destroyed lesser machines. By providing a dependable foundation for heavy military mobility, it enabled the development of larger transport systems and shaped decades of Soviet off-road vehicle engineering. KZ-KT 7428 Rusik Heavy Tank Transport Beyond Roads. The KZ-KT 7428 Rusik was developed to solve one of the most demanding problems in modern land warfare: how to move main battle tanks and other ultra-heavy armored vehicles across terrain where paved roads are absent, damaged, or deliberately avoided. Designed as a true off-road tank transporter, the Rusik combined immense pulling power with mobility, suitable for mud, snow, sand, and frozen ground. Development of the KZ-KT 7428 took place during the late 1970s to early 1980s at the Kurgan wheel tractor plant. It was conceived as a successor to earlier heavy tractors, addressing the increasing weight of Soviet main battle tanks such as the T-72, T-80, and later variants. Rail transport and highways limited flexibility and made movements predictable. So, the military required a tractor that could haul tanks deep into undeveloped areas while remaining independent of fixed infrastructure. The KZ-KT 7428 is an 8-wheel drive heavy tractor built specifically to tow massive semi-trailers, carrying armored vehicles weighing more than 60 metric tons. The tractor itself weighs over 25 metric tons and is powered by a high-output diesel engine designed to deliver extreme torque at low speeds. This allowed it to pull tank transporters across soft soil, snow-covered terrain, and frozen surfaces without relying on prepared roads. A defining feature of the Rusik is its off-road-focused chassis design. Large, low-pressure tires, a reinforced suspension system, and permanent all-wheel drive allow it to maintain traction under heavy load. Central tire inflation enables crews to adjust ground pressure depending on terrain, improving mobility on sand, mud, or ice. These features made the KZ-KT 7428 particularly effective in northern regions and during winter operations, when frozen ground expanded operational routes far beyond road networks. The cab of the KZ-KT 7428 was designed for long-duration missions in harsh environments. It is enclosed, heated, and equipped with navigation and communication systems suitable for extended off-road convoys. Crew endurance and reliability were prioritized, as breakdowns while hauling tanks in remote areas could cripple entire operations. In service, the Rusik was used primarily by heavy transport units responsible for redeploying armored formations. It enabled tanks to arrive near combat zones without consuming their own track life and fuel reserves, preserving combat readiness. Unlike road-bound tank transporters, the KZ-KT 7428 could bypass damaged infrastructure, river crossings, and predictable routes, increasing operational flexibility. The vehicle's limitations were largely logistical. Fuel consumption was high, maneuverability was restricted by the length of the tractor-trailer combination, and maintenance required skilled crews. However, these trade-offs were acceptable given its unique capability. The KZ-KT 7428 Rusik stands as a purpose-built solution for moving the heaviest ground weapons beyond the reach of roads. By combining raw towing power with true off-road mobility, it filled a critical role in military logistics and remains one of the largest and most capable tank transport systems ever designed for unprepared terrain. Oshkosh M1070HET, America's heavy equipment transporter. The Oshkosh M1070 heavy equipment transporter was developed to meet a critical requirement of modern U.S. military logistics: the ability to move main battle tanks and other oversized armored vehicles quickly, safely, and independently of rail networks or fixed infrastructure. Built for extreme loads and long-distance off-road movement, the M1070 became the backbone of American heavy ground transport operations. Development of the M1070 began in the late 1980s, with the vehicle entering service during the early 1990s. It was produced by Oshkosh Truck Corporation as part of a complete heavy equipment transporter system paired with the M1000 semi-trailer. This system was designed specifically to transport the M1 Abrams main battle tank, one of the heaviest armored vehicles in service, weighing over 60 metric tons. The M1070 is an 8-wheel drive tractor, powered by a high-output diesel engine delivering exceptional torque. The tractor alone weighs more than 20 metric tons, and, when coupled with the M100 trailer, forms a transport system capable of carrying loads exceeding 70 metric tons. Its length, mass, and structural reinforcement place it among the largest wheeled military vehicles ever operated by Western armed forces. Off-road capability was a primary design goal. The M1070 features permanent all-wheel drive, heavy-duty suspension, and large low-pressure tires optimized for soft ground. Central tire inflation allows the crew to adapt to mud, sand, snow, or loose soil in real time. These features enable the transporter to move heavy armor across unpaved routes, desert terrain, and frozen ground, expanding operational flexibility far beyond highway use. The cab is designed for long-duration missions and harsh environments. It is fully enclosed, climate-controlled, and equipped with advanced navigation, communications, and diagnostic systems. Crew survivability and endurance were prioritized, allowing sustained operations in extreme heat or cold without sacrificing performance or safety. The M1070 entered widespread operational use during the 1990s and proved its value in multiple large-scale deployments. It enabled rapid relocation of armored units without excessive wear on tank tracks and engines, preserving combat readiness while reducing logistical strain. Its ability to bypass damaged roads and operate in austere environments made it essential during expeditionary operations. Limitations of the system include high fuel consumption and reduced maneuverability when operating in confined terrain. Maintenance requirements are also significant, reflecting the stress imposed by extreme loads. However, these factors are inherent to vehicles operating at this scale and were accepted trade-offs for its capability. The Oshkosh M1070HET represents the American approach to heavy military mobility, robust, reliable, and purpose-built for global deployment. By combining massive towing capacity with off-road performance, it secured its place among the largest and most capable off-road military transporters ever built. Oshkosh M1300 LVSR, high-capacity off-road logistics giant. The Oshkosh M1300 LVSR was designed to solve a problem that defines modern expeditionary warfare: how to move large volumes of supplies, equipment, and mission-critical payloads across terrain where roads are unreliable, damaged, or completely absent. Built as a heavy logistics platform rather than a tank transporter, the LVSR emphasizes payload flexibility, endurance, and off-road reach at an exceptionally large scale. Development of the LVSR began in the early 2000s, with the vehicle entering U.S. Marine Corps service during the late 2000s. Oshkosh Defense engineered the M1300 as a replacement for older heavy logistics trucks, reflecting a shift toward expeditionary operations that required sustained mobility across deserts, mud, snow, and broken ground. Unlike strategic missile carriers or tank haulers, the LVSR was intended to keep entire forces supplied while operating far forward. The M1300 features a massive 10x10 drivetrain with all wheels driven, providing exceptional traction under heavy loads. Depending on configuration, the vehicle weighs more than 25 metric tons empty and can carry payloads exceeding 16 metric tons on its own chassis, with significantly more when towing trailers. Its length and wide stance place it among the largest operational logistics trucks in military service, optimized for stability when hauling tall or uneven loads. Off-road performance is central to the LVSR's design. Independent suspension, large, low-pressure tires, and a central tire inflation system allow crews to adapt instantly to sand, mud, snow, or rocky terrain. The vehicle is capable of climbing steep grades and traversing soft ground that would immobilize conventional logistics trucks. This capability allows supply routes to shift dynamically, reducing dependence on predictable road networks. The LVSR is highly modular. It can be configured to carry flatbed cargo, containerized loads, fuel systems, engineering equipment, or recovery gear. A key feature is its compatibility with load handling systems that allow rapid self-loading and unloading, reducing exposure time and manpower requirements in forward areas. This flexibility makes the M1300 a core asset for sustained off-road operations. Crew survivability was a major consideration. The cab is armored, climate-controlled, and designed for long-duration missions in extreme environments. Advanced diagnostics, navigation, and communication systems allow the vehicle to operate independently while remaining integrated with broader logistics networks. Operational use has demonstrated the LVSR's value in expeditionary contexts where speed of resupply and terrain flexibility are decisive. Its size, power, and adaptability allow it to support heavy forces without the need for extensive infrastructure. The Oshkosh M1300 LVSR stands as a modern logistics giant, proving that off-road military power is not limited to weapons platforms alone. By enabling large-scale supply movement across the harshest terrain, it plays a decisive role in sustaining military operations where conventional logistics would fail. Fawn SL-T-50 Elephant, Europe's heavy armor transport solution. The Fawn SL-T-50 Elephant was developed to address one of the most demanding logistical challenges faced by European armies during the Cold War: the movement of increasingly heavy main battle tanks across terrain where rail lines and highways could not always be relied upon. Built in West Germany, the Elephant became one of the largest and most powerful wheeled military vehicles ever produced in Europe, designed specifically for off-road armored transport at extreme weight. Development of the SL-T-50 began in the late 1960s at Werke, with the vehicle entering service during the early 1970s. It was engineered to support the Bundeswehr's armored forces, particularly the Leopard 1 and later heavier variants that demanded robust transport solutions. The strategic goal was to move tanks rapidly without consuming track life or fuel, while maintaining the ability to operate beyond paved infrastructure. The SL-T-50 is an 8-wheel drive heavy tractor paired with a massive low-loader semi-trailer. The tractor alone weighs over 20 metric tons and is powered by a high-output diesel engine optimized for torque rather than speed. When combined with its trailer, the system is capable of transporting armored vehicles weighing more than 50 metric tons, placing it firmly among the heaviest off-road military transporters of its time. Off-road capability was a core requirement. The Elephant features large, low-pressure tires, permanent all-wheel drive, and a reinforced suspension system designed to cope with uneven ground, mud, sand, and snow. Central tire inflation allows rapid adjustment to changing terrain, improving traction and reducing ground pressure. These features made the SL-T-50 effective not only in Central Europe, but also in colder and less developed regions during NATO exercises and deployments. The cab was designed for endurance and reliability. It is fully enclosed, heated, and equipped with navigation and communication systems suitable for long convoys and extended operations. Crew comfort was not a luxury, but a necessity, as missions often involved hauling massive loads over long distances under challenging conditions. Operational use of the SL-T-50 demonstrated its value as a force multiplier. Tanks could be repositioned rapidly without mechanical wear, arriving ready for combat while preserving maintenance cycles. Its off-road capability also allowed transport routes to bypass damaged infrastructure or avoid predictable movement corridors. While later vehicles such as the SLT-56 would surpass it in payload capacity, the SLT-50 established the standard for European heavy armor transport. It proved that wheeled systems could reliably move the heaviest ground weapons off-road and played a decisive role in shaping NATO heavy logistics doctrine during the latter half of the Cold War. Von SLT-56, Franziska, Cold War. Weight moved off the highway. The Von SLT-56, Franziska represented the peak of European heavy armor transport during the later Cold War, built to move the heaviest tracked vehicles of its time without relying on railways or fixed road infrastructure. As armored vehicles grew heavier and more complex, existing transporters reached their limits. The SLT-56 was developed to solve that problem decisively, pushing wheeled military logistics to a new scale. Development of the SLT-56 began in the late 1970s at Werke in West Germany, with the vehicle entering service during the early 1980s. It was designed as the successor to the SLT-50 Elephant, addressing the increasing weight of armored platforms such as later Leopard variants and other NATO heavy equipment. The goal was not just higher payload capacity, but improved off-road performance under extreme load. The SLT-56 is an 8-wheel drive heavy tractor paired with a reinforced low-loader semi-trailer. The tractor alone weighs more than 25 metric tons and is powered by a high-output diesel engine engineered to deliver exceptional torque at low speeds. When coupled with its trailer, the system is capable of transporting armored vehicles exceeding 60 metric tons, placing it among the heaviest wheeled military transporters ever operated in Europe. Off-road capability was a central design requirement. The SLT-56 features permanent all-wheel drive, a strengthened suspension system, and large low-pressure tires optimized for soft ground. Central tire inflation allows the crew to adjust ground pressure while moving, improving traction on mud, snow, sand, and frozen terrain. This capability enabled armored units to maneuver beyond predictable road networks, increasing operational flexibility and survivability. The cab of the SLT-56 was designed for long-duration missions under harsh conditions. It is fully enclosed, heated, and equipped with navigation and communication systems suitable for extended convoy operations. Crew endurance was essential, as moving heavy armor off-road often required slow, deliberate travel over long distances with minimal external support. In service, the SLT-56 allowed tanks and other heavy vehicles to be redeployed without excessive wear on tracks and drivetrains. This preserved combat readiness while reducing maintenance demands. Its ability to bypass damaged bridges, congested routes, and vulnerable infrastructure made it especially valuable in contingency planning across Central Europe. The SLT-56 demonstrated that extreme weight did not have to be confined to highways or rail lines. By combining massive towing power with genuine off-road capability, it enabled the movement of Cold War armored strength across terrain once considered inaccessible. As a result, it stands as one of the most powerful and capable heavy military transport systems ever built on wheels. Tatra 813. Kolos. Central Tire Engineering at monumental scale. The Tatra 813. Kolos was one of the most distinctive heavy off-road military vehicles produced in Eastern Europe, combining massive scale with an unconventional engineering philosophy that set it apart from its Western and Soviet counterparts. Built by the Czechoslovak manufacturer Tatra, the Kolos demonstrated that extreme off-road mobility could be achieved not only through sheer engine power, but through intelligent chassis and drivetrain design. Development of the Tatra 813 began during the mid-1960s, with the vehicle entering service in the late 1960s to early 1970s. It was designed to meet Warsaw Pact requirements for a heavy logistics and transport vehicle capable of operating across unprepared terrain, including mud, snow, sand, and rough ground. The increasing weight of military equipment demanded a platform that could haul large loads while remaining independent of paved roads. The Tatra 813 Kolos featured an imposing 8x8 configuration and weighed over 20 metric tons empty, depending on variant. Its most defining feature was Tatra's signature central backbone tube chassis, combined with independently suspended swinging half-axles. This design provided exceptional torsional rigidity, while allowing each wheel to maintain ground contact over uneven terrain. The result was outstanding off-road stability for a vehicle of such size. Power came from a large air-cooled V12 diesel engine mounted ahead of the cab, delivering strong low-end torque suited for heavy hauling rather than speed. The Kolos was capable of towing substantial loads, including artillery, engineering equipment, and heavy trailers. Large low-pressure tires and a central tire inflation system allowed crews to adjust traction on the move, improving performance on soft or slippery surfaces. The vehicle's dimensions and mass made it one of the largest wheeled military trucks in service at the time. Its high ground clearance, protected driveline, and sealed components enabled operation in harsh climates, including cold weather environments where mud, ice, and snow often combined to defeat conventional trucks. These characteristics made the Tatra 813 suitable for long-distance off-road convoys and support missions far from established infrastructure. The cab was designed with durability and endurance in mind. It was fully enclosed and could be equipped with heating and basic protection systems, allowing crews to operate for extended periods under demanding conditions. While not as specialized as missile carriers or tank transporters, the Kolos filled a critical heavy logistics role, bridging the gap between standard military trucks and extreme strategic transporters. The Tatra 813 Kolos proved that innovative chassis engineering could rival brute force solutions in off-road performance. By pairing monumental scale with a unique mechanical layout, it delivered mobility and reliability that earned respect across multiple armed forces. As a result, it remains one of the most significant and capable heavy off-road military vehicles ever built. Tatra 815-7. Force, extreme terrain mobility for heavy military loads. The Tatra 815-7. Force represents the modern evolution of heavy off-road military transport, combining decades of proven engineering principles with contemporary requirements for mobility, protection, and payload flexibility. Designed to operate where terrain is unstable, infrastructure is absent, and conditions are unpredictable, the 815-7 Force demonstrates how heavy military logistics has adapted to 21st century operational realities. Development of the Tatra 815-7 Force began in the late 2000s as part of Tatra's effort to modernize its military vehicle lineup while retaining the core mechanical concepts that defined earlier designs such as the Tatra 813 and original 815 series. The vehicle was developed to meet NATO and export requirements, emphasizing interoperability, modularity, and extreme off-road capability rather than sheer size alone. The 815-7 Force is built around Tatra's signature central backbone tube chassis, with independently suspended swinging half-axles. This design allows exceptional torsional rigidity while keeping all wheels in contact with the ground over uneven terrain. Depending on configuration, the vehicle is available in 6x6, 8x8, and heavier layouts, with gross vehicle weights exceeding 30 metric tons. This places it firmly among the largest modern off-road military trucks designed to carry heavy payloads across unprepared ground. Power is provided by a high-output diesel engine optimized for torque and reliability, paired with a heavy-duty transmission and permanent all-wheel drive. Central tire inflation enables real-time adjustment of tire pressure, allowing the vehicle to adapt instantly to sand, mud, snow, ice, or rocky terrain. High ground clearance and a protected driveline further enhance survivability and mobility in harsh environments. The Tatra 815-7 Force is designed as a highly modular platform. It can be configured as a heavy cargo carrier, tanker, missile system support vehicle, recovery truck, or armored logistics platform. This flexibility allows a single chassis family to support a wide range of missions, reducing logistical complexity while maintaining heavy load capability. Crew protection and endurance are central to the design. The cab can be armored to modern standards and is fully climate-controlled, supporting operations in extreme heat or cold. Integrated navigation, communications, and diagnostic systems allow the vehicle to operate independently for extended periods while remaining connected to command and logistics networks. Operational use has shown the 815-7 Force to be particularly effective in environments where heavier strategic vehicles are impractical, but standard trucks are insufficient. It bridges the gap between extreme missile carriers and conventional logistics vehicles, delivering heavy loads into areas where roads do not exist or cannot be trusted. The Tatra 815-7 Force illustrates how advanced chassis engineering, rather than sheer mass alone, can define off-road dominance. By combining proven mechanical concepts with modern systems and modular design, it stands as one of the most capable heavy military vehicles built for extreme terrain mobility and sustained off-road operations.